Corporate finance practice problem using OneNote. Coefficient of variation 3 investment alternatives. Get ready, it's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side in the practice problems area, then down in the 1316 coefficient of variation 3 investment alternatives tab. Also note, when using OneNote, look at the immersive reader tools. Many of our presentations up top will be mirrored down below in the text area, same name, same number, but with transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we have our information up top. We'll go through the calculations on down below. We're going to imagine a situation. We're going to have 3 different types of investment opportunities, and we're going to go through our similar type of analysis we've seen in prior presentations to try to get an idea of what the outcomes might be for each of those 3. So the 3 outcomes then, or the process that we will be using for the investments, is try to think about the range of what a good return would be, the not so good and a very good types of returns. You don't really need the name categories over here. You need basically the return categories. And then we'll basically put together what we expect to be the case under a not so good, good, and very good type of scenario. We'll typically want between 1 and 5 types of categories and then weight those categories in some way. You might ask, well, how would you do that? You might look at past performance to see what happens in the past and then make projections or predictions about what's going to happen in the future, and then see if you can get basically probabilities or likelihood. This structure can start to formulate or frame your thinking so that you can hopefully make a logical decision about them. So we're going to do that for basically option 1, option 2, option 3. Imagine these 3 different investments with 3 different alternatives that we are imagining could happen and the probabilities of those happening. So, and all this is projections. So when I'm talking about the probabilities and whatnot, of course, in these amounts of the returns, we don't know. We're looking out into the future. We're trying to format our thought in as systematic a way as possible to get to as clear a thought process to try to think about the future as we can. So we're going to say that not good, we got the 400 times the 20%. That's going to give us the 80. The 800 times the 20% is the 160. And the very good is going to be our most likely option, we believe, possibly the economy going up or something like that. And we're thinking that it's going to be what we expect to happen. 1,350 times the 60% is the 810. Obviously, all the percentages need to be adding up then to the 100%, that's going to be our expected return. So we expect then the return based on this analysis to be the 1,050. For option 2, we're going to say 700. If it's not good, average, we're going to say is the 1,400 times the 20%, or the 280, and then the very effective, the 2,050 times the 60% is the 1,230. Obviously, these add up to 100% as well. Note that we have different dollar amounts between option 1 and option 2, investment 1 and investment 2. However, the probabilities are the same. And then in investment 3, we're thinking we have the 750 at the 40%. So now we have different probabilities here. So the 40% times the 750, 300, the 2,550 times the 40% is the 1,020, and the 4,050 times the 20% is the 810 for a total of 2,130. These adding up to 100 as well. So between these 3, the last option has our greatest expected return. We got the 2,130 versus the 1,650 and 1,050. The next thing we might want to look at then is going to be the level of risk. So we might want to consider and think about what's going to be the level of risk, what's going to be the level of variation then from this number, which is basically the expected value, which you could think about as kind of the mean or the average. Average, mean, same thing, and the basically expected value in this term and is in essence the same thing as well. Now note, if this one had the highest expected value, it could possibly come out to the situation where there's actually less risk for the higher one. So if this one had less risk and a higher expected value, then it would be a fairly clear choice. But if you're in a situation where this one has higher expected value but more risk, which is often the case, that's when you're trying to compare between what you want to do, right? If this one had a higher expected value and less risk, then not really a question. If it has a higher expected value and more risk, then the question is, do we want to be taking on the more risk because of the higher potential value that we could have? And that could depend on what your risk aversiveness is. Are you risk averse, or do you not mind risk? And what your portfolio basically looks like, what you're looking for in terms of return versus risk. So let's break that down a little bit further then. We're gonna take this down a bit different way here. We're gonna say the returns on this first investment. We're back to the first investment now, the 400, the 800, the 1,350. We're looking at the expected value, which is basically the average, and comparing that out now. That's the expected value of the 1,050. And we'll take that all the way down. So the 400 minus the 1,050 is the negative 650. The 800 minus the 1,050 is the negative 250. And the 1,350 minus the 1,050 is the 300. Now we're going to go through our process and square that. So let's do the first one just with our trusty calculator here, squaring the first one. So we're going to make it squared, which will be 650 negative, and then square it, which is going to be 422,500. So we're going to say that's going to be 42225. The 250 squared is negative 250 squared. It's a positive 62.5. 300 squared is the 90,000. Then we're going to apply out our probabilities, which are the 20-20-60 in this case, 20-20-60. So the 422,500 times the 20% is the 84,500. The 62,500 times the 20% is the 12,500. And the 90,000 times the 60% is the $54,000. Then if we add those up, the 84.5, the 12.5, the 54,000, we get the 151,000. That's going to be the variance. It's in squared units. So then oftentimes we want to take the standard deviation, which is the square root of that number. So if we took the 151,000 and square rootized it, which would be this little key, that would be the 388.59. And then we're going to take that and compare it to the expected value, which is basically the mean or median, to give us the coefficient of variation. So in essence, we're taking that number divided by the 1050, which we calculated up top. That gives us the 0.3001 about rounded. So this number then is, not very helpful in and of itself, but when compared to the other investment options could give us an idea, and we'll apply that idea to basically the level of risk involved. So let's take a look at the second one and do the same thing then. Same thing for the second one. Returns are going to be now the 700, the 1004, the 2050. We take the expected value, which is the 1,650, all the way down. Take the difference between the two. The 700 minus the 1,650 is the negative 950. The 1,400 minus the 1,650 is the negative 250. And the 2,050 minus the 1,650 is 400. We're then going to square it. Square all of them, those three numbers. So let's take the 950. We're going to make that negative and then square it. We got the 9025, the 9025, and then we've got the 250 squared is the 62.5, the 400 squared is the 160. Probabilities then applied, that's going to be the 20-20-60, 20-20-60. We got the 9025 times the 20% is the 185, the 62.5 times the 20%, 12,005, and the 160,000 times the 60% is the 96,000. We add those three numbers up, we get to the 289,000, that being the variance. Then we're going to take the standard deviation, which would be the square root of that, 289,000, taking the square of the root, rooting the square root, and that's going to be the 539.59 about. And then we compare that to the expected value we got to up top to get to our coefficient of variation. That's where our key focus is going to be, dividing out by the 1650, the 0.32858. So that we're going to do a comparison between that and the first one in a second, but let's do the last one first. So we will do the comparisons, but hold on, let's do the last one first. I know it's exciting to now compare those two, but we'll do this and then we'll compare them. Patience, patience. We have the 750 and then the 2550, the 4050 expected value. That's going to be the 2130. Then the difference, 750 minus the 2130 is the negative 1380. 2550 minus the 2130 is the 420, and the 4050 minus the 2130 2130 is the 1920. Squaring those items then, let's just do the first one again. We're going to take the 1380 negative and square it is the 1,904,400. The 420 squared is the 176,400, and the 1920 squared is the 3,686,400. Applying the probabilities, that being the 40, 40, 20. So the 1,904,400 times the 40% is the 961,760. The 176,400 times the 40%, 70,560, and the 3,686,400 times the 20% is the 737,280. Adding those three numbers up, we're at the 1,569,600, that being the variance. We're then taking the standard deviation, the square root of the variance. So we'll take then the 1,569,600 square root, and that's going to be the 1,252 or 1,253 about, rounded. And then we'll compare that to the expected value, which we got up top, the mean or the average, in other words. So taking that divided by the 2130 gives us the 0.5881, which is the coefficient of variation. So now let's consider those three. This one's going to be the least risky because it has the lowest coefficient of variation. So this one's the least risky, and then the second least risky is the 3701, and then the third least risky is going to be this item down here according to the coefficient of variation. So remember, with regards to the return, this one had this one down here had the highest expected return, but it also has the most risk related to it. So if we take a look at these two up top, we've got the 1,050 and the 1,650. And now between these two, notice this one has a higher expected return than this one, and it's less risky. So in that case, it's not usually a difficult decision in that case. If our expected return is higher and it's less risky, then most likely we would want to be choosing the second option as opposed to the first option. That can happen. And again, oftentimes when you think about finance, you start thinking, well, the higher risk, the higher the reward. And that's true. But just remember that, the risk going up does not necessarily mean that the reward is necessarily higher, right? It's just so, you got to weed out the bad ones, which means that that's not the case. When that is not the case, when the risk goes up and the reward is not higher, the potential reward is not higher, that's not good. The question is which ones do have a higher, basically, return with the increased risk, right? So between these two, you'd probably be looking at the second one, and then you'd be comparing the second one and the third one, and then this one is a situation where you have a higher expected return and it's more risky. Which would be then the question would be, do we want to take on the added risk in order for the potential expected future return? And when you're asking that question, now that you've narrowed down to that being the question, then the question is, well, are you going to be risk averse type of personality, or do you not mind risk in order to get a higher return or possibly have the probability of getting a higher return? And or what am I looking for with regards to the other factors that are in my current situation, whether that be a portfolio or my business structure? Does this fit well within my overall business structure, what I need with regard to risk level and where my current investments are possibly with regards to risk level and my diversification on a broader kind of spectrum?